All right, so now we're going to look at how we can find the distance from a point, in this case, the point 6, -2, to a line. In this case, the line y equals 2x minus 4. Now, the thing is like, well, there's no graph. Like, what do we do? Because we're not given a graph, we're not given like a picture or anything. So like, it's going to be up to you to kind of come up with your picture or your diagram and whatever. So all you really need to do is draw like a sketch, not even like a sketch, just a visual of what's going on here. So, start off with drawing this line. And again, you just have to draw it so that it makes sure that it follows a positive slope. So this will be our line. This will be the line. Y equals 2x minus 4. And then we have to see like where this point is relative to this line. And you really just want to see if it's going to be above it or below it. That's really the main thing. Um, so what you can do is just pick the coordinate x equals 6 on the line, and then see what the y value is when x equals 6 on this line. So if I plug in 6 into here, I'll get 12 minus 4, so I'll get 8. So then on the line, we're going to have a 0.68. And since we're looking at the 0.6 -2, we know that the 0.6 -2 is going to be below it. We'll just say it's something like over here, or probably even further down. I'll probably be. Let's give this point a name. Let's give it a lower letter. Let's give it let's call it point Z. So 6 -2. So we have to calculate how far this point is from this line. And yeah, you can't just draw any random line and just, find the distance. We want to find the length of a perpendicular line. So let me try to see if I can get this down. All right, that'll do. And we're going to call this line y2. And we're going to call the point where it intersects, we'll call that, let's call it W. So this line y2 makes a right angle because it's perpendicular to this line. And remember, we need it to be perpendicular because a perpendicular line segment is going to be the shortest distance from a point to the line. So ultimately, we want to find, your goal is to find the length of WZ. That's your ultimate goal. Now, we need to find where the point W is located at, though, because if we can't find WZ unless we know where W is located at, and we can start off by knowing that Z is at 6 -2. Now from here, since this line is perpendicular to this line, we can go ahead and begin our journey by making y2 equal to the reciprocal slope, or the opposite reciprocal slope of y1. Now let's call this y1. Let's say this is y1, y1. So for this to be perpendicular, remember the slope of the lines have to be opposite reciprocals. And since this is 2, the slope of y2 will then be -1/2. Because remember the slope of this line, we'll call it m1, is +2/1. So the opposite reciprocal of 2/1 is -1/2. So then we know y2 is going to be something like -1/2 x plus b. So we have to find the y-intercept of this line. And for that, we'll just plug in the point 6 -2 and for y and x. So we'll have -2 equal to -1/2 times 6 plus b. And we can solve for b using good old math. And we get that b is 1. If b is 1, Then y2 will be equal to negative 1/2 x plus 1. So that's the equation of y2. Don't worry, there's still a lot more to go. So we know that the equation of y2 is negative 1/2 x plus 1. So we can find where point W is located at by setting y2 equal to y1, because at this point, y1 and y2 are going to have the same coordinates. So we're going to go ahead and make y1 equal to y2. So let's go over here. I don't like bending over. I'm too tall. So we're going to go and write 2x minus 4 equal to negative 1/2 x plus 1. So now we can solve this for x. So working our way, let's add half of x each. Let's add 1/2 x to each side, and let's add 4 to each side. So we get 2x plus 1/2 x. That'll be 5/2 x equal to 5. Because remember, 2x is the same as 4 over 2x. 4 over 2. So we add 4 and 1. Now, to solve for x, let's write this as a fraction. Get rid of this 2 by multiplying both sides by 2 over 1. These cancel, and we get 5x is equal to 10. Divide by 5. And we'll get that x is equal to 2. Now, if x is equal to 2, we can find y by simply plugging in 2 into either y2 or the y1 equation. It doesn't actually matter because they're both going to be the same at this point. So I'll just plug it into there. So plugging that into, let's say plugging that into y1. y1 will be 2 times 2 minus 4. And we'll get that y is 4 minus 4, y is 0. And again, I put y1 just because I use that equation, but it doesn't matter. Like that y is just the same y value. And so the point now, w is going to be at the coordinates 2, 0. So now w is at 2, 0. Oh wait, there's more. Now we can finally use the distance formula to find the length of WZ. Because now we know the coordinates of W and Z. So using the distance formula, I don't know what I'm doing. Let me write it over here. All right, let me write it. Let me write it over here. So WZ is equal to, remember the distance formula, the whole, let me write it down here in case you forgot. The distance is equal to the difference of the x coordinates squared plus the difference of the y coordinates squared. All, whoops, and you're taking the square root of that. So then we just pick x2 minus x1. So then we can go 6 minus 2 squared plus negative 2 minus 0 squared. 6 minus 2, I'll give you 4 squared, plus a negative 2 squared, which will give you 16 plus 4, or the square root of 20, which will then be about 4.47 units. Simple. All right, so there you go. Again, be careful to make sure that you don't like do any rounding. Like if some of the problems you're going to see that you're going to have more fractions, try not to round or approximate till the very end because you're going to get like miscalculations throughout the problem. So just wait till the very end if you're going to round or convert it to decimal. All right, so good luck. See you guys in the next video.